Welcome to Trending Unpacked, the show where we explore the stories behind the trends shaping our world. Today, we're digging into something that felt less like a trend and maybe more like a collective digital heart attack. When AWS goes down, the world really feels it. I want you to think back, just for a second, to that day in October 2025, the day the internet kind of broke. You were probably there, right? You try to open Slack, maybe hop on a quick video call.
Nothing.
Exactly. Dead air. Or you jump over to Spotify, Netflix, whatever, to just escape the frustration.
And you get the spinning wheel of doom.
Or the app just hangs. Everything felt glitchy, didn't it? Essential services, things you rely on, just stuttering.
Yeah, or those weird generic error pages popping up everywhere.
It was so frustrating, and it happened instantly, all at once, to millions of us around the globe.
And that shared experience, that collective groaning, that's really why we need to unpack this. It wasn't just, a small glitch somewhere. It was like a huge set of dominoes falling over. Which brings us to the big question we need to tackle for you today. How can just one company failing Amazon Web Services, AWS round, how can it have that much power? Enough power that when it stumbles, it creates this massive, simultaneous global impact, hitting millions of people, big-name companies, services that seem totally unrelated, all at the same time.
Okay, yeah. Let's follow that digital trail. Let's figure this out. If AWS is really the single point of failure that sends ripples across the entire world, well, we need to get past just calling it a cloud service, don't we? We need to understand the actual, the scale of what we're dealing with here.
That's absolutely critical. People hear AWS and they think, okay, website hosting, maybe storing some photos or data. But that view is, honestly, it's dangerously incomplete. AWS isn't just a service. It's more like the fundamental plumbing, the invisible backbone of so much of the modern internet. It provides the huge infrastructure that makes our complex digital lives even possible. We're talking databases tracking everything, the networks routing unbelievable amounts of traffic, the raw computing power for AI models.
Security systems too, right? Protecting all that data.
Exactly.
Yeah.
All of it running on their hardware in their data centers.
And the numbers we found in the sources, they really back this up. It's kind of staggering. AWS powers over 30% of the global internet infrastructure. Just let that sink in. Over 30%.
It's a massive chunk. It's hard to even visualize what that means, but it's this huge concentration of the digital world sitting on essentially one company's foundation.
So 30%, what does that actually translate to? Who are these users?
Well, yeah, that 30% means they have effectively a dominant position in so many critical areas.
Yeah.
And think about who relies on that. It's not small blogs, generally. It's giants like Netflix. They need AWS to stream, billions of hours of video smoothly.
Right.
Twitch needs it for live streaming, that low latency stuff that has to work in real time. But it goes way beyond just entertainment. Think about crucial institutions, government agencies. Even NASA uses AWS heavily.
NASA! Wow, for what?
Storing complex scientific data, running big simulations, managing these high-performance computing tasks, things that absolutely cannot fail. Or, well, shouldn't fail.
So it's like when AWS gets a hiccup, it's not just that you can't watch your show, it's that global commerce, entertainment, maybe even core scientific work just pauses.
He gets momentarily paralyzed, yeah.
Yeah.
And that highlights this enormous centralized risk that's just baked into how our modern digital world is built.
Okay, so that brings us right to the event itself, the October 2025 outage. AWS is huge, global, but the actual problem started somewhere specific, right? Though the impact was definitely worldwide.
That's right. The technical fault might have been geographically contained, but its blast radius was enormous. We saw major services, things people rely on daily, Slack, for instance, essential for so many businesses working remotely.
Totally. Can't function without it sometimes.
Airbnb's booking systems, their payment processing, Spotify's main playback features, all of them either went completely offline or were seriously degraded.
And not just for a few minutes, right? This went on for hours.
For hours, yeah. Which feels like an eternity when you depend on these things.
And this event, it really showed that symptom of centralization you mentioned.
Perfectly. Even if the initial technical glitch was relatively small, because thousands of different seemingly independent services all rely on some of the same underlying AWS control systems or infrastructure.
That single failure point starts a chain reaction.
Exactly. A cascade. It's a very public, very painful demonstration of how concentration amplifies technical fragility.
One thing that really stands out from the sources, and it's important for you, the listener, to get this, This wasn't some freak accident, was it?
No, not at all. That's the worrying part. This 2025 failure isn't an isolated incident. It joins a, frankly, troubling list of previous major AWS outages. We saw big ones in 2020, 2021, 2023.
So there's a pattern.
There's definitely a pattern. It shows the systemic risk is real, it keeps happening, and it hasn't been fully solved yet, despite their best efforts, clearly.
But AWS is meant to be like the gold standard for reliability, right? They talk about redundancy, resilience. So how does the system keep failing like this? What are the actual technical reasons behind these repeated crises?
Well, the causes often sound surprisingly simple on the surface, but the effects are just catastrophic. Often it boils down to internal technical problems, things like network misconfiguration, someone setting up the network rules incorrectly.
Human error, basically.
Sometimes, yeah. Or fundamental power disruptions in a data center.
Right.
That can happen. And maybe one of the most common culprits, especially in recent incidents, is what's called API overload.
Okay, API overload. Break that down for us. What's an API in this context?
Sure. Think of an API that's application programming interface. Think of it like a digital waiter for a server. You make a request, I need this piece of data, or I want to perform this action. The API takes that request to the kitchen, the server, and brings back the result.
Got it. Like ordering food.
Exactly. Now, API overload is like a massive sudden rush hour at the restaurant. Everybody tries to order at the exact same moment. Too many requests hit that digital waiter simultaneously. The system just gets overwhelmed.
A digital traffic jam at the server's front door.
Precisely. The internal mechanisms, the kitchen, they just can't keep up with the flood of orders, and the whole system can grind to a halt or start failing unpredictably.
Okay, that makes sense. A flood of requests breaks the interface.
Yeah.
But I'm still stuck on the redundancy part. AWS invests so much in having multiple data centers, these availability zones, right? Designed so if one fails, others take over. So why does a failure, like an API overload, still seem to cascade so widely? That's where this US East region comes into play, isn't it?
That is absolutely the critical point. And yeah, this is where it gets a bit technical, but it's crucial to understand. AWS structures its infrastructure using regions. These are large geographic areas,
Yeah.
like North America, Europe, Asia. And within each region, they have multiple availability zones, or AZs.
And AZs are the separate data centers, physically separate.
Yes, physically distinct data centers, often miles apart, with independent power, cooling, networking. The whole idea is isolation. If one AZ goes down due to a fire, flood, power outage, whatever,
The others in that same region should keep running, and services fail over.
that's the design. That's the promise of resilience. However, the sources consistently point to a specific vulnerability, a kind of Achilles heel in the U.S. East region, specifically U.S. East 1, located in Northern Virginia.
Okay, why Virginia? What's so special or maybe vulnerable about that specific spot? Isn't the whole point of the cloud to be distributed, not reliant on one place?
It seems counterintuitive, right?
Yeah.
But U.S. East 1 is historically significant. It was the first AWS region, and it often hosts many of the core control plane services for AWS globally, or at least for North America.
Control plane, what does that mean?
Think of the control plane as the management layer, the brain maybe, or the master key ring for the whole AWS ecosystem in that area. Crucial services like IAM identity and access management, which figures out who you are and what you're allowed to do.
Like logging in?
Exactly. Or the core databases that track the configuration of all the other services. These critical command and control functions are often heavily concentrated in US East 1.
Ah, I see. So even if my actual website data or application servers are running fine in a different AZ or even a different region.
If the control plane in US East 1 goes down, those other services might lose their instructions. Or, more critically, users and other services might not be able to authenticate. They can't prove who they are to access the resources.
So the healthy parts become inaccessible, like locked rooms you suddenly can't get the key for.
That's a great analogy. The cascading failure isn't necessarily that all the servers physically break. It's that the central command and coordination system fails. The loss of the control plane is what triggers the widespread outage.
Okay, so the redundancy concept itself isn't necessarily flawed, but its implementation has this centralized dependency, this choke point in the control mechanism, often in Virginia.
That seems to be the recurring issue, yes.
And that explains why seemingly unrelated services, thousands of them, can just blink out simultaneously no matter where their primary servers are located.
Yeah.
Wow. Okay, so this massive technical failure obviously has huge consequences for the companies relying on AWS, the corporate fallout. Even if AWS doesn't release exact figures, What kind of damage are we talking about? Economic, reputational?
Oh, the cost is immense, and it hits on multiple levels. First, there's the immediate direct economic loss. Lost e-commerce sales, for example.
Right.
Imagine a major online retailer during a peak shopping period. Hours of downtime means millions in lost revenue, just gone. Poof.
Or Airbnb, like you mentioned, losing booking fees every minute the site is down.
Exactly. Transactional revenue that you just never get back.
Yeah.
Then there are potential regulatory headaches. Depending on the industry, think healthcare finance. There are strict rules about data availability and access.
Like GDPR or HTA.
Right. If an outage prevents a company from accessing critical patient data or financial records needed for compliance, they could face significant fines, legal action. It gets serious fast.
And that's just the direct money side. There's other damage too, isn't there? More subtle, maybe?
Absolutely. The reputational cost is often the kicker, the one that lasts the longest. Think about it when Slack goes down or Spotify stops playing music. Who do users blame?
They blame Slack or Spotify. They don't think, oh, AWS US East 1 must be having an issue.
Exactly. The company whose app you're using takes the heat. They pay the price in frustrated users, negative social media buzz, lost customer trust, potentially people switching to competitors. It erodes confidence.
And I guess there's also the internal costs, like what the company's own teams have to deal with.
For sure. Think of all the expensive engineering hours suddenly diverted from building new features or improving the product to just firefighting, trying to diagnose the problem, implement workarounds, communicate with customers. It's a massive, unplanned, costly scramble.
So the outage forces this big strategic question onto these companies, doesn't it?
It absolutely does. It forces them to seriously confront the risk. Can we actually afford not to invest potentially millions in diversifying our infrastructure, maybe using multiple cloud providers, building better fail-safes? That whole debate about cloud monopolies and single points of failure, it stops being theoretical. After an event like this, it becomes a very real, very expensive business risk assessment.
Okay, so a huge technical failure with massive corporate consequences. But it didn't just stay contained within tech circles or boardrooms, did it? This thing exploded onto the global stage. It became a cultural moment almost instantly.
Immediately. The reaction was, well, visceral is a good word for it. The second thing started to feel broken. People didn't just sit around waiting for AWS to update its official status page. That often comes later anyway.
Right, you feel it before they announce it.
Exactly. So where do people go? They flood onto the platforms that are still working, usually competitors, ironically, like X, formerly Twitter, or Reddit.
So do what? Just complain.
Partly, sure. But mostly to confirm they weren't alone, to see if everyone else's digital world was also crumbling. It's this need for collective validation. Is it just me, or is everything broken?
And the sources confirm this, right? The social media chaos was instantaneous. It went from a technical problem to this global cultural meltdown almost.
Absolutely. People weren't just passively waiting. They were actively demanding answers, seeking reassurance, and just sharing the sheer frustration of it all.
The speed of it was incredible, too. You mentioned the hashtags.
Yeah, things like hashtag internet down, hashtag AWS fail. They apparently hit millions of mentions within just a few hours.
Billions.
That sheer volume, that speed, it just shows how deeply woven these services are into the fabric of daily life. When you suddenly lose the tools you use to work or connect or just unwind, the immediate instinct is to talk about that loss.
And it was fascinating how people started sharing screenshots, wasn't it? Those error messages, the spinning wheel.
Yeah, it became like this weird collective proof. See, this is what I'm seeing. You too.
It wasn't just complaining. It was like creating a shared artifact of the failure, a digital marker saying we were all here experiencing this bizarre global glitch together.
Exactly. It created this strange, temporary sense of global community united by shared digital frustration.
Which naturally led straight to the internet's primary coping mechanism.
Tech humor, sarcasm, memes.
Of course.
The situation is maddening, right? It's complex, it's completely outside your control as a user. So what's left? You make jokes.
I remember seeing so many memes flood my feed. The sources mentioned this explosion of humor.
It's that digital shrug, isn't it? A way of collectively saying, well, this is absurd, but at least we can laugh about how absurd it is.
What kind of themes were popping up?
Oh, the classics. Jokes about, finally having to talk to people in real life.
Yeah. Or digging out actual physical books.
Dusting off the board games, that kind of thing. And interestingly, brands got in on it too. The sources mentioned companies posting tongue-in-cheek responses.
Acknowledging the shared pain, sort of?
Yeah, partly acknowledging the shared vulnerability. It makes the brand seem a bit more human, maybe. But it also highlights the sheer craziness of the situation. You have these giant, multi-billion-dollar companies all effectively paralyzed by the exact same invisible infrastructure failure. There's an inherent dark humor to that level of dependency.
But it wasn't all just memes and jokes, was it? When things break down on such a massive scale and information is scarce, especially early on, that's when the less humorous side of the internet tends to kick in, the conspiracy theories.
Oh, absolutely. When uncertainty meets widespread disruption, the darker corners of speculation always light up. The leap from something's broken to we're under attack is incredibly fast. And it tells you a lot about our anxieties, really.
Because the outage was so sudden, so widespread, hitting so many different things at once.
It instantly fueled this intense speculation about external causes, malicious intent.
It couldn't possibly just be a mistake, right? It had to be bigger, more sinister.
That's the human tendency, isn't it? Especially with complex systems we don't fully understand. A failure of this magnitude feels like it must have a correspondingly dramatic cause. So immediately you saw the narratives emerge online. This has to be a state-sponsored cyber attack. It's hackers. Or even wilder stuff.
Like what?
Oh, AI taking over. A dry run for a total digital collapse.
Yeah.
People find it really hard to accept that something as mundane as a faulty power supply in Virginia or a single mistyped command could actually bring down such a huge swath of the digital world.
They want a villain. Or at least a plot.
Exactly. A grand narrative makes more sense somehow than a simple, albeit catastrophic, mistake.
And this is where we have to lean hard on the facts, right? What the sources actually indicate. We need to fact-check the panic.
Absolutely critical. We have to stress this for you, the listener. The sources we reviewed, the official reports that eventually come out, they consistently find no evidence to support these kinds of speculation-driven theories. The documented causes almost always trace back to internal technical issues, human error, power failures, those complex API cascades we talked about, maybe hardware failure.
So it's usually more boring than the theories suggest.
Often, yes. Much more mundane, technically speaking. And that's a key takeaway. In a digital crisis, our instinct might be to jump to conclusions about attacks, but reality is often rooted in a less dramatic, centralized technical flaw. Relying on verified information, not speculation, is crucial.
Okay, beyond the immediate reactions, the memes, the conspiracies, the outage seems to have sparked something deeper too, a kind of cultural reflection. The sources called it the dependency reflection theory.
Yes, and this, I think, is maybe the most profound consequence of an event like this. The outage acts like a giant social mirror, forcing us to stare at our own deep reliance on these invisible systems. We've built modern society, really, on the assumption that the digital infrastructure will just be there, like electricity or running water, your banking app, your work tools, your medical records portals.
You just expect them to work.
You expect them to work flawlessly all the time. So when they suddenly vanish, even temporarily, it's a shock. It forces us to confront just how incredibly dependent our lives, personal, professional, financial, have become on infrastructure we almost never think about and certainly don't see.
And that connects to what the sources called the digital fragility insight, right? This idea that the cloud isn't some magical mist.
Exactly. We use that term, the cloud, so much that it becomes abstract, ethereal, almost mystical.
And it's not.
It's absolutely not. And that abstraction is dangerous because it hides the physical reality. The cloud is concrete. It's millions upon millions of physical computer servers whirring away in huge buildings. It's massive air conditioning systems sucking up enormous amounts of power. It's fiber optic cables snaking under the oceans. It's complex software written by humans.
All concentrated in specific physical locations like those data centers in Virginia.
Precisely. So when the cloud fails, it's not magic disappearing. It's physical infrastructure. A server rack overheating, a power line being cut, a software bug being deployed failing under the immense load we place on it. It's a warehouse full of hardware glitching out.
So if we connect that back to the user's emotional reaction, the panic, the frustration, it's not just about, oh no, I can't listen to my Spotify playlist right now.
No, it runs deeper than that. It's the sudden, jarring realization of how little control you actually have. Your ability to work, to manage your money, to access healthcare information, even just to socialize, it's all subtly, visibly reliant on these huge, centralized systems. Systems you have zero insight into and absolutely no control over.
The panic comes from feeling vulnerable.
I think so. It's a response to realizing just how radically vulnerable you are. Your digital life, which is increasingly just, your life is essentially being rented from a tiny handful of gigantic faceless corporations. And when the service blips, that feeling of trust evaporates for a moment. You feel powerless, adrift, subject to the decisions and failures of an infrastructure you can't even see.
That feeling of vulnerability, that powerlessness, it leads us perfectly into the final part of our analysis. Looking at the core structural issue that the 2025 outage really threw into sharp relief, this problem of centralization, and maybe what the path forward looks like for resilience.
Right. That October 2025 event was basically a multi-billion-dollar real-world experiment proving the centralization risk theory. We talked about that staggering number, AWS controlling over 30% of the global internet infrastructure.
Yeah.
When you concentrate that much critical digital function into one single provider, you are, by definition, creating systemic risk. You're putting all your digital eggs in one enormous, globally connected basket, as the saying goes.
And it's not just about efficiency, is it? It's about how that concentrated power inherently creates concentrated risk for everyone who depends on it.
Absolutely. The modern internet is overwhelmingly reliant on the big three cloud providers: AWS, Google Cloud, GCP, and Microsoft Azure. Between them, they basically hold the keys to most global connectivity. It's an oligopoly, really.
And that structure itself creates fragility.
It inherently creates these points of centralized fragility. One significant misconfiguration, one major power outage, especially in a critical control plane region like US East 1, and the ripple spread globally, instantly taking down thousands of vital applications. It's a known flaw, kind of accepted, but a fundamental vulnerability in the architecture of today's digital world.
Okay, so if this risk is known, and it keeps happening, we've seen major outages in 2020, 2021, 2023, now 2025, it begs the question about diversification. Why aren't more big companies, especially those who can afford it, building proper fail-safes, spreading their systems across multiple clouds like AWS and Azure, or AWS and Google Cloud?
Yeah, there's a real irony there, isn't there? The tech industry talks constantly about cloud resilience, disaster recovery, high availability, while simultaneously often concentrating their core dependencies in single geographic regions like US East, or relying entirely on a single provider.
So why not diversify? Is it just too hard, too expensive?
It's mostly complexity and cost, yes,
Yeah.
and something called vendor lock-in.
Interlock-in, what's that?
Okay, so when a company builds its applications on AWS, for example, it naturally starts using AWS's specific tools and services, maybe their unique database systems or specialized AI services, or particular ways of managing network traffic.
Tools that work really well within the AWS ecosystem.
Exactly. They're optimized for AWS. Now, trying to take that complex application, which is deeply integrated with those specific AWS services, and make it run seamlessly on, say, Microsoft Azure or Google Cloud.
It's not just copy and paste.
Not even close.
Yeah.
It often requires a massive re-engineering effort.
Mm.
You have to rewrite parts of the application, figure out equivalent services on the other platform, manage data synchronization, build complex orchestration to automatically switch traffic between providers if one fails.
That sounds really expensive and time-consuming.
It is. Significant investment, deep technical expertise. For many companies, historically, the perceived cost and complexity of building a true multi-cloud, actively redundant system seemed higher than the perceived risk of a major outage on their primary provider.
Until the risk becomes reality, like in October 2025.
Precisely. The calculation changes after a major event like this. The sources strongly suggest that avoiding single provider dependency needs to shift. It can't just be a background technical concern anymore. It needs to become a strategic board-level priority. The companies that had already invested in multi-cloud strategies, the ones that could dynamically shift their workloads away from the failing AWS region.
They weathered the storm much better.
They paid a much, much lower price during the outage, both financially and reputationally. The ones who were all in on the single provider bore the full brunt.
So if centralization is the core problem and diversification, while hard, is part of the answer, what's the bigger picture? What's the path forward to address this fragility for the future internet?
Well, if concentration is the problem, logically the solution has to involve some form of decentralization. We need to move, theoretically and practically, towards architectures that are inherently more distributed, less reliant on these few massive choke points.
What does that look like in practice?
It points towards technologies that are already emerging. Things like edge computing, for instance.
Edge computing, that's about processing a data closer to where it's actually generated or used,
Yeah.
right? Not sending everything back to a giant central data center.
Exactly.
Right.
Processing data at the edge, on devices, in local network hubs, closer to the user. This inherently reduces the reliance on those huge centralized cloud regions for certain tasks. We're also seeing advances in AI-driven load balancing, systems that can intelligently, automatically, and almost instantly shift application traffic, not just between servers in one cloud, but across different cloud providers, different geographic regions, based on real-time performance and health monitoring.
So making the failover much smarter and faster.
Much smarter, much faster, and potentially across multiple providers. The idea is that the highly centralized cloud model, while incredibly efficient in many ways, might just be hitting the limits of its ability to provide global scale stability and resilience. We might need a more hybrid, more distributed future.
This whole analysis, it really brings us back to the individual user, doesn't it? Back to you, the listener, whose work stopped or whose movie wouldn't play. The outage wasn't just a technical event. It was this really profound, maybe uncomfortable reminder of how much we all rely on infrastructure that's almost entirely invisible to us.
And largely misunderstood. We trust these systems implicitly, day in, day out.
Yeah.
We trust them to handle our money, our communications, our health data, our entertainment. We trust them completely, but we're generally not equipped to fix them when they break, or even really to understand why they broke. The internet, the cloud. It works so incredibly well most of the time that we forget its underlying nature. We forget it's just a vast, complex machine, a collection of physical hardware, running code written by humans, housed in real buildings, susceptible to power outages and human error.
So when that trust is broken, even for a few hours.
The massive reaction, the frustration, the panic, the memes, it's all just a symptom of suddenly confronting that fundamental, perhaps excessive reliance we have on this hidden, vital machinery that powers modern life.
That's a really powerful thought to end on, that the complexity, when it's invisible, just makes the shock and the anxiety worse. When things inevitably do go wrong, it really underscores the fragility hiding beneath the surface of our connected world.
And maybe that leads us to the final thought for you to consider. Perhaps the scariest thing about the internet going dark isn't really the downtime itself. It's that moment you realize how little you actually understand about the massive, complex systems you trust, almost everything.
A sobering thought indeed. That wraps up our look into the fallout from the October 2025 AWS outage and what it tells us about digital resilience. Thanks for joining us for this exploration. Next time on Trending Unpacked, we switch gears completely, moving from digital breakdowns to real-life mysteries with The Perfect Neighbor, a story that digs into how well we really know the people living right next door. Until then, stay curious.